splice the two back into one single thing before I upload. So that's going to be a little bit fun because sometimes the time frame they don't sync up exactly. So we'll go ahead and I'll deal with that. So don't worry about that one. All right. So we're going to use Linux to do homework assignments in this class. How many people are planning to move on to cisp310 after this class? Doesn't have to be like next semester, but eventually. Okay, that's not a whole lot of hands. So okay, let me change the question then. Why are you here? Are you getting a transfer degree? If you're getting a transfer degree, chances are you need to take cisp310. And guess who's teaching cisp310? And guess what environment you'll be using to do your homework assignments?
The same.
Exactly. So you learn it once and you can use it in both classes. Okay, so that's it's definitely not time wasted. Okay, so what we'll do today during the lab time is to do your homework. Okay, so if you want to follow along, that's fine. If you want to just kind of sit back and make sure you can absorb the material, that's fine with me too. Yep, go ahead.
You can use Linux on a Mac, right?
You can run Linux on a Mac using Q, which is actually the QEMU emulator that runs on the Macintosh.
Okay.
Yep, so it will still kind of work out, but you will have to download the executable by yourself and have it installed.
Okay.
Yep, but it'll still work. All right, so what I'll do is I'm going to get started with your homework assignment, which is lab activities, setting up a Linux environment. Okay, so that is the homework. And if you click on it, it will take a little bit of time to load up. There we go. Okay, this is your homework assignment. It is what we're going to do in the lab, like what you're going to do here. The first thing you have to do is to click here, and the word here is a hyperlink. So you can just click that. Or if you want to, you can select this text here and then just say, open in a new tab. Either way works. So I'm just going to click here, right click, and click open in a new tab. That will bring you to Google Drive, because it's a pretty big file. I don't want to put it onto the power server or anything like that. So I put it onto Google Drive, and you can click this symbol, download, to start the download process. It will give you a warning because Google doesn't want to scan 0.75 gigs of stuff for virus, so it won't be scanned by Google. So I'm going to download this. It's pretty fast because I'm using the school's own apps server, so it's pretty close to Los Rios. So this will still take some time. If we're all doing the same thing, it's going to take longer. So I will just kind of let it do this while I go over the homework assignments. So after you download the file, which will take a little bit of time, you can unzip the file. This is just a regular zip file. When you unzip the file, it will create one folder called Linux, Linux in all lowercase. Now the trick is you can unzip this file, which is pretty big, onto any drive. There's no installation needed. You don't need administrative right to make use of this. Okay, you can just unzip it onto a thumb drive. If you have a thumb drive with you today that has about 3 gigs of space left, you can go ahead and do it on that thumb drive. Okay. And I'm just going to move forward here to do the description because it's going to take a little bit of time to download. So once you unzip everything into a folder, inside the Linux folder you will find 2 batch files. The first batch file is called start32.bat and the second one is called start64.bat. And the name implies which one you need to use. You have to find out whether you have a 64-bit version of Windows or a 32-bit version of Windows. If you have 32-bit, you use start32.bat. If you have 64-bit, you use start64.bat. Okay? And if you are using a Mac, you have to use Q. The name of the software is just Q, the letter, but that's the QEMU emulator for Macintosh, for Mac OS X. And once you start up, it will give you a virtual machine. Okay, it will start up a virtual Linux box. How many people are somewhat familiar with the concept of a virtual machine? Okay, a few. Okay. A virtual machine is basically a computer, but it's not real. Okay, it is emulated by software, and in this case, Windows is called the host operating system. Okay, in other words, it is the operating system that is directly running on top of the hardware of this box. When you run an emulator, it has the ability to pretend to be another computer. Okay, and in this case, I'm using Linux as a guest operating system, which is the one that is running inside the virtual machine. From many perspectives, there's no distinction between a real physical PC and a virtual machine, because a virtual machine works pretty much the same way as a real machine, other than it does not have a physical form. And it's still downloading. You know, it's at 150. I'm suspecting there are quite a few people in this class also downloading at the same time. And there's no caching, you know, so that there's only one connection to the outside world. So this will take a little bit of time because we are all downloading at the same time. The emulator that I have chosen to use is not VMware or VirtualBox. Now those two are quote-unquote commercial products. They work great, but there's one downside to those two products. You need to install it. Okay. Now I want to make this so that you can plug in your thumb drive to any Windows computer and be able to do your homework. That is my objective, with or without internet access. So that means, with this installed on the thumb drive, you can take that thumb drive to the library, assuming those computers also have USB ports, plug it in, navigate to the folder, double-click on Start 64 or Start 32, and be able to run the virtual machine and do your homework. That is my objective, and that's why I am not using VMware or VirtualBox, because both of those products require installation, and you cannot install that software on other computers. So QEMU has one downside. It is a little bit slower than the other two products, but for what we are doing, it's not going to be a big deal. Since it's still downloading, I'm just going to keep talking until it's done downloading. When you use QEMU for the first time, you might be surprised sometimes and say, where's my mouse pointer? Okay, because it might disappear. If you click in the console of QEMU, it will quote-unquote grab your mouse pointer, which means you won't see your mouse pointer anymore. You have to type Control-Alt-G in order to release the grab on your mouse pointer. So don't panic, just read the title text of the console and it will tell you what to do to release the mouse pointer. Second thing is, when it is time to close the emulator, like when you're done with your homework assignment and you have to move on, try not to click the close button of the emulator, because it has a close button kind of like this one here, up at the top. I guess you cannot see it. But it's just like any other Windows application. It has a close button. If you click the close button, it will be the same thing as me yanking this power cord out of this desktop computer. Is that a good thing to do? Not necessarily, right? The file system I use in this particular virtual machine is fairly resistant to that sort of thing. Okay, so in the worst case, you probably will just lose 1 or 2 files. But I don't want you to take that risk. So there will be a discussion of what is the proper procedure to shut down a Linux box. So we'll talk about that. And number 3 is there are 2 additional programs in addition to QEMU in this distribution. One is called PuTTY, P-U-T-T-Y, and the other one is called Winscp, W-I-N-S-C-P. Those 2 programs are really useful, not only for this class. Anytime you want to connect to another computer running SSH as a server, these 2 programs can be useful. PuTTY is kind of like a dumb terminal program. You can basically run as many CLIs or command line interfaces as you want using PuTTY. And Winscp is a file transfer program. You can transfer files between Windows and the Linux virtual machine using Winscp. Are there any questions? Yep.
Do we have a server like that?
Your virtual machine is the server. Yep.
Macs have it built in right through the terminal?
Yes. Macs have SSH as a command as well as SCP as a command. Yep. All right. And since we're still downloading, I'm gonna keep talking until this is done downloading. Moving a file into the virtual machine. So the next step of this homework assignment is for you to download this file into Windows first, and then you move it into the virtual machine. If you're running Linux natively, you don't have to do any of this. But if you're running Linux as a virtual machine, then this is an extra step that you have to do. This file, quote unquote, this file is, you can just go ahead and download it and click save link as. And you can see the name is, well, maybe you cannot. The name is test.tar.gz, okay? Don't bother to open this in Windows because Windows doesn't know what to do with it, okay? And you don't have to, okay? Just go ahead and save this file to a folder where you can remember where it is. So I'm just going to download it to my downloads folder. Click save. All right, so I'm done with this step here. And I really can't do any further, cannot do anything further than this because I need my virtual machine in order to do the rest. So I'm just going to take a little break here and try to answer any questions that you might have about virtual machines. So are there any questions about running virtual machines? No questions? Go ahead.
So you said if you have the Linux in a real operation system, you don't have to do the extra step in the Windows.
That is correct. If you're running Linux natively, then you have all the tools already, and you can just use that environment to do your homework assignments.
Can I install this version of Linux in my operation system?
Can you?
Can I install this version of Linux in my operation system? Home?
Yes, you can. Yep. You have to make sure that you have G++ installed. You have to make sure that you have all the necessary tools and libraries installed. Okay. And we're still waiting for the file to download. We are at 420 megabytes right now, so it will take just a little bit. Sorry?
407.
407. Well, if you guys let me go through this first, that will, allow me to kind of move forward a little bit faster. But that's okay. So I think you can right-click and pause the download process. And yesterday, last night, I was demonstrating basically the same thing, but I was using my Linux environment. So I was running Windows 7 as a virtual machine and then running Linux as a virtual machine inside Windows 7 as a virtual machine. And that worked. It was slow, but it worked. And this particular virtual machine will take up about half a gig of RAM. If you're running short on RAM, on your computer, you can probably shrink the memory use down to maybe 384 megabytes or even less, maybe 256 megabytes, and it will still work. And when was the last time you have an application that only takes up 1/4 of a gig of RAM? I was sitting in Professor Dumas' office the other day. I'm just killing time because of the download. And he was showing me his new computer running Windows 8.1, I think. It's not Windows 10, it was 8.1. And he showed me, see, this is the reason I run, Windows 8.1 because it doesn't use up that much RAM. And he showed me how much RAM it was using. And this was just the operating system. He did not even start a browser. It was 1.9 gigabytes of RAM. And then I told Larry, Professor Dumas, and I said, my office machine in my actual office, number 7 of room 133, only has 2 gigs of RAM. So if I install Windows 8.1, it would just use up everything already, just the operating system. I don't need to run anything, at all in my office. I run Linux usually in my office, and after loading up everything, it will use up maybe about 0.7 gigs of RAM. I will still have room to run the virtual machine on that thing. It's one of the last gateway computers on this campus. It finally died last year. Okay, last year the IDE controller finally died on that computer. So I told the IT people and say, "Oh, my computer just died. What are you guys going to do about it?" They went to the warehouse and found another computer exactly like that to replace it. I was impressed a little bit. I think it's a dual core. It's a Core 2 dual core, processor running at 1.8 gigahertz or something like that. The hard drive has 160 gigs. 160 gig.
It's like the throwaway laptop I brought in my backpack. It's because if I drop it or something, I won't feel bad.
Yep, that's the kind of processing power I use in my office. Yep.
Is there anything you can tell us about Linux and why you use it?
Well, I just told you one reason, right? It doesn't take up a lot of resources. Two, I don't use any Microsoft specific, software. So I use LibreOffice, and these days I don't even use LibreOffice all that much. I just push everything to Google Drive. It's easy. It is, I don't do anything that really is top secret. It's not like, I have the secret plan of the next, spy plane or anything like that. So if someone breaks into Google Drive and can see all my documents, it's not a big deal. And it's just, handy, because I can redistribute it any way I want to. And I can also rescue a damaged Linux installation just like that, as opposed to Windows, because if it's not open source, I cannot try to fix it. Yep, that's one of the big reasons. And it's getting there. It's almost 600 megabytes. About 14 years ago, 2001, and I was telling people in my department, in the CIS department of all departments, and I told the department and say, well, you guys need to learn about Linux. I mean, this is going to be useful. And I was teaching my students, at that time, how to use Linux and the advantages of using Linux and so on and so forth. One of my colleagues, came to me and said, "Tack, you should stop doing this, because you are doing a disservice to your students, teaching them something that they cannot use in industry." I'm hoping you're not feeling the same way. Yep.
I actually can't help but notice the trends of people, the companies, industries moving away from proprietary software where they have to pay huge amounts for licenses to free, really available operating systems.
It is, I cannot remember the year, but IBM was one of the first companies to switch to Linux. They used to maintain their AIX, which is a proprietary Unix, full Unix operating system, and then they found out it's not worth the money to maintain their own operating system. So they switched to use Linux as the de facto standard operating system on their servers, and they contribute back to the open source community. So IBM is kind of interesting because it is definitely a for-profit company, but it's also one of the main contributors to open source components in Linux. Same thing with HP, they made the switch about the same time as IBM. Yep, it's getting there. And how many people have Windows or planning to install Windows 10?
I've got Ubuntu. I'm happy.
Yeah, I don't really find a whole lot of need to run Windows programs. Mostly games, but even the games are now starting to migrate to Linux. It's a slow migration because of NVIDIA refusing to open source their hardware.
I mostly need Windows just for my CAD programs. So Autodesk is Windows only. Otherwise, I'd be using.
Can you whine it?
I could whine SketchUp, which is Google's.
Okay.
But the AutoCAD and Revit, Inventor, SolidWorks, no go.
You can run Windows as a virtual machine inside Linux.
I thought about it, like Revit, SolidWorks are huge. Those take up a lot of RAM, so I don't know how slow they'd be running.
Yep. All right, we only have 40 something megabytes to go. We're crawling our way there. Yep.
So you're using Debian as your Linux distribution?
Yep.
Why did you choose Debian as opposed to an RPM-based?
Well, at the time that I chose to use Debian, it was a better distribution system, and I also like Debian having the three different distributions. They have the unstable, testing, and stable. So on servers, I tend to use the stable one, because I don't really want to update everything like very often. But on the desktop, I just use the unstable. So I kind of like the ability to choose, whether you want the more recent software and trade stability for that, or you want to just stability and not really care about the latest version of stuff. And I don't want to spend all my time recompiling stuff, like with what is that distribution that recompiles everything? Gen 2. All right, we are almost there. 1 more megabyte, and we're done. Oh, it's measured differently. Well, there's megabyte and then there's megabytes, right? Because one is metric and the other one is in binary. It's finally done. Okay, great. All right, so I'm going to open up this file. So when you open up a zip file, in Windows, it will give you something like this. Don't even bother to look into here, until you have unzip it into a separate drive. So I will just go ahead and click Extract All Files and extract it to my thumb drive. So I'm going to browse, go to Computer, go to my external drive, which is H drive, and click OK, click Extract. And this will take a little bit of time, but not nearly as much time as downloading it because it's just writing to an external hard drive. If you use an external hard drive, you will see about the same speed as what you're seeing here, which is pretty quick. If you use a thumb drive, on the other hand, you might be seeing a really small fraction of the speed that you're seeing here. And the reason why that is the case is a lot of flash drives are really slow to write to. So if you're writing gigabytes and gigabytes of stuff, to an external thumb drive, it might be very slow. An external hard drive is pretty quick. It's getting there. And by the way, this is a USB 2.0 connection, so it's not even USB 3. That's why it's, sometimes it gets a little slow. There's one huge file that it has to decompress, and that one is probably the one getting decompressed at this point. The speed is 22 or 20 plus megabytes per second, which is actually respectable for USB 2.0 connections. This computer is definitely slower than the other one in the other classroom. If you use a thumb drive, the slower ones, you might be seeing 5 megabytes per second.
1 megabyte.
Did you get a Patriot drive?
Yeah, that's really good.
Okay. Yeah, but the Patriot brand is awful from Fry's. All of the ones that I bought with that brand name, they did not last long. They're slow. It's just not worth it. All right, so I got everything decompressed already, and it's all decompressed into a Linux folder on my H drive, which is right here. Okay, so double click, open up that, and you will see what we talked about a little bit earlier. You should see start32.bat and start64.bat. There's a shell file here for those of you who want to run a 32-bit version of Linux in a Linux environment. Not useful for this class, okay? So in this class, if you have any type of Linux environment, you're good to go. And in the case of Mac OS X, you might be able to install just G++ and the tool chain natively on a Mac to get it to work. So in the previous semester, some people were able to do that. So to find out which version of Windows you have installed on a particular machine, you just have to go to Control Panel, go to System and Security, and just check the amount of RAM and processor speed. It will tell you in this case we have a 64-bit operating system. So I should be using start64.bat in the batch files. So I can close this one. One and double click this. Go. It will get some warning, because it complains about it's an unknown publisher and stuff like that. And you might get a firewall warning too, because the virtual machine wants to open port 2200, which is normal. Okay, so don't be alarmed when you have that pop up. All right. So this is a virtual machine. It looks just like starting up on the regular computer because it is a pretend computer that is pretended in software. And because it's emulated, it will run a little bit slower than usual. So it will take a little bit of time to start up. Are there any questions about what we are doing? What a virtual machine is, and okay. Does anyone run any emulator other than QEMU or this sort? Do you guys play Nintendo games, console games on the PC? Yeah, that's a really popular use of emulators. All right, so it's all done. It took about 2 minutes or so to start up, which is not stellar in terms of speed, but it's not a big deal. So now that we have the virtual machine started, we can follow the instructions. The instruction says, we have to move this file from Windows into the virtual machine. And the tool to do that is Winscp. So if you go back to the Linux folder, you can find winscp.exe, which is an executable. You can just double click it and start up Winscp. And by the way, SCP stands for secure copy, okay? So it is basically a sub-protocol of SSH. All right, so you will get this screen, and just click Run, okay? So this part is important, okay? How do you connect to the virtual machine to transfer files? The host name is localhost, because the virtual machine is not really a separate machine. It is running on the very same box, in the same box as your Windows, software. So that's why, when you connect to it, it is using localhost as the host name. The port number, the default is 22, and you have to change it to 2200 because the emulator cannot take over port 22 because it's a low number port, but 2200 is okay. The username, the default username is just user, and same thing for password. So the password is user as well, all lowercase. So once you have done all of this stuff here, you can click Login. When you click Login, it will give you a warning like this to basically make sure that you know which machine you're connecting to. So in the real setting, if you're doing anything that is sensitive, you have to check the fingerprint against the actual fingerprint of the server that you're connecting to. Because there's a possibility that people can launch a man-in-the-middle attack on something like this. You don't have to worry about it when we're doing the homework like this way. So just click yes to accept the fingerprint. And now we have the main screen of Winscp. Winscp separates the screen into two parts. The left-hand side is your local, quote-unquote local, or Windows file system. The right-hand side is on the virtual machine, which is the Linux side. So what we need to do now is to copy that file that we have downloaded a little bit earlier to the Linux side. And that was in my downloads folder. So I would double-click the two dots here to go to the parent folder, go down to downloads, and here's the file that I'm supposed to copy. The other side is already at the home folder, so it's already at the right place. So to copy this is pretty easy. Drag, drop, click OK, and we're done. So are there any questions about copying a file from Windows to the Linux side, to the virtual machine? No questions? All right. So now that we have this file on the other side, on the Linux side, we can now run certain commands to get it going. And I'm going to use the console of QEMU. At some point in this class, we will start to use PuTTY instead of just the console. The problem with the console is there's only one. Okay? So you are going to use the same screen to run the commands, to do the editing and all kinds of stuff like that, which is not undoable, it is just inconvenient. If you use PuTTY, you can open up as many quote-unquote windows as you want. So you can have one that is just running the editor, one to run the compiler and the commands, one to run GDB to debug your program. It's just more convenient that way. But for this homework assignment, it's not a big deal. So go ahead and log in as user, and the password is user. Now in Linux, when you type a password, it does not echo back anything, not even asterisks. So when you type, it doesn't seem like you're typing anything, but you are. So press the enter key. With the right password, you will be logging. You can log in as user. Several commands will be useful. One is list. ls is list. It will show you the files in the current working directory. Now, how do you know where you are in the file system? This little thing here. Okay, I'm not sure how well you can see it. Let's see if I can magnify this. So I can zoom in. And maybe one more time. There we go. Okay, so you can see this little tilde symbol. That means you're in the home directory. Your home directory is now your current working directory. Whatever you do, if you don't specify the file path, it's going to be in your home directory. This is the file that we have just copied a little bit earlier. You have to uncompress the tar.gz file. The command is tar xzvf, the v is optional, and then the name of the tar.gz file. Press the enter key and it will confirm that it creates a folder called test, and in the folder it has a file called check.pl. It is a pro file. Are there any questions about this step? It's actually documented in the homework description itself, so if you cannot follow here, it's all already written down in the descriptions. So the next thing you have to do is to go into the folder test. CD stands for change directory. This is how you can move the working directory from one place to another place. Then you have to say CD test, because we want to change the working directory to the test subfolder. So now we are in the test subfolder. The command line interface in Linux, by default, always show you where you are. So you can see that we were in the home directory, and now we are in the test subfolder of the home directory. The next thing we have to do is to run the command itself, check.pl. We can do another ls if you want to, and you can see that it uses color highlighting. Anything that you can run is in green, any compressed file is in red, and folders are in blue. Okay, so to run check.pl, you cannot just say check.pl. You have to say // to mean that we want to run this in the current directory. You press the enter key, it does something. All it does is to collect some statistics from your machine. That's all it does. Nothing really too important. But to do the homework, this will leave no trail, so I have no idea whether you got this part done or not. So to do the homework assignment, you're going to have to run the same command /check.pl, but with a greater than symbol next to it, and then check.log. Okay? What this will do is it will capture the output of this program, and instead of displaying the content, the output on the screen, it will capture the output into a file, and that file is check.log. Is that okay? Okay. So we press the enter key, and you can see that this time it does not give me any output on the screen because the output is now captured to the file called check.log. Now, if you go back to Winscp, you can actually check whether it is done correctly or not. If I go back to Winscp, which is still running, it doesn't refresh automatically. If it does not, you can just go ahead and click refresh, and you can see that there's a folder called test. Double click on that folder, you can see that we have the command called check.pl and also a file called check.log. Now, Winscp is really kind of useful because you can actually right click here and edit or open the file. And what it does is it will copy the file from the Linux side to the Windows side and then open up an editor so you can actually view the content and also edit it if you want to. Okay, it's a good mechanism. It's a useful mechanism to check that you are working correctly. You're working on this one, following all the steps. So when this is all done, you have to create a new tar.gc file and turn it in. So this is how you do it. Okay, to create the tar file that you're going to turn in, you have to run this command inside the test subfolder. And the command is a little bit long. It is spelled out in the homework description itself, but I'm going to do it here. It's tar czvf /test done, and the done with an uppercase D, .tar.gz. So everything is case sensitive, okay? Gotta remember, in Linux, everything is case sensitive. Dash uppercase C / and then backtick, which is the key at the upper left corner of the keyboard, right below the escape key, pwd, and then backtick again. That's a pretty long command, okay? So I'll go ahead and explain a little bit of what this command is doing, just so that you know what it is and be able to diagnose problems if you run into any problem. TAR, T-A-R, stands for tape archive. And this was the command that people use when they still back up stuff on tape, okay? But it turned out to be a really useful utility program, and they kept adding stuff to it. So this is basically the de facto command in Linux to back up stuff, okay? Folders, an entire drive, it doesn't matter, they just tar everything up. czvf is a combination of flags, or what we call switches, that are kind of like parameters to a command. C stands for create. Z is zipping, okay? It is compressing the files. V is optional. It means verbose, okay? It will give you a lot of feedback when you run the command. F means what is following this is the name of the file that it is creating. So we are creating this file here. What does tilde mean, again, when we specify a path using tilde? The home directory. The home directory, exactly. So this is basically saying testdone.tar.gz is not going to be created in the current working directory. Instead, it will be created in the home directory. Is that okay so far? Okay. Here we have dash uppercase C. It changes the folder to the root folder of the entire file system before we specify what we're compressing. And then backtick pwd backtick will basically substitute that portion of the command line with the current working directory, which is this one here. So that's the quick explanation of this particular command. Any questions about this one? It might take you a few tries to get it right, okay? Because it is a long command with lots of opportunities to make mistakes. If you do it right, you will see this as the output. Do not be alarmed when it gives you this warning, okay? tar : removing leading slash from member names, that's perfectly okay. It is normal to complain about this. But you should also see what it is compressing or what it is including in a tar file. It will be everything inside the test folder. Are we still doing okay so far with the command and the way it works? Okay. If I switch back to Winscp at this point, go back to the home folder and do a refresh, F8, you will see a new file. In addition to test.tar.gz, now we have a new file, testdone.tar.gz. And that is the file that you have to turn in Moodle. But hold on a second here. This is on the virtual machine. It's not accessible to Windows just yet. So the next step is to copy this file back into Windows. Drag and drop. Just make sure you remember where you drop it, because otherwise you'll have problems uploading it. So once you drag and drop it, remember, I put it into the downloads folder. So back in Moodle, what you need to do is to go to the end here. I signed in as professor. Let me see if I can change to a student again. The reason why it didn't work the first time was because I did not take the test correctly. So let's see. Yep, it didn't let me do it because Moodle thinks that I have not done the interactive syllabus yet, so I'm going to have to redo it. And by the way, if you did it and you answer something wrong, you can always redo it. You have an unlimited number of attempts. Okay. It's either that or I forgot to click something last time, so I'm going to make sure I click everything. All right, so let's see. Okay, back to the class. And now I have access to the homework. There we go. All right, so back to the homework assignment. So this is me, as a student, and you should see the same thing on your end. So when you scroll all the way to the bottom of the screen, you should see a button called Add Submission. Click that button, and you'll be presented with an interface to upload a file. So click this interface, or you can drag and drop a file. I'm not going to drag and drop here. So if you click it, it will ask you which file do you want to upload. So click Choose File. Go to, well, I put it into the Downloads folder. And remember to upload testdone.tar.gz and not the original test.tar.gz file, because that one does not have what you have just done earlier. So make sure it's testdone.tar.gz. Click Open and click Upload this file. We are 2 steps away from getting everything done. Okay. So you might think you're done here because it is quite obvious that Moodle has this file called testdone.tar.gz. If you do not click Save Changes, it's not going to be saved, and I won't be able to grade your homework assignment. So make sure you click Save Changes. And then after that, you can see that you have a link to the file that you have just uploaded. This is confirmation that you have uploaded the file correctly. Now, what if you turn in something and then you just remember, you know what, I ran the command differently and I'm not sure whether what I turned in is correct or not, and you want to turn in something else, okay? If you want to turn in something else, you can go to Edit Submission. Now, when you get to Edit Submission, it will give you the file that you have just turned in. You cannot upload anymore. There's no interface here to upload another file, and that's because in the homework assignment, I only specify that you can upload up to 1 file, and that file is already here. So if you want to replace this file, the first thing you have to do is to click on it and then click delete. Okay, you want to get rid of the file that you have just uploaded so that you have room to upload another file. So between now and next, I'll give you guys a whole week to do this. So between now and 9 o'clock next Wednesday, you can resubmit as many times as you want. There's no limitation. So are there any questions about any of the steps that we have performed a little bit earlier? Hopefully the recording is on and we got everything on the recording. Yep, go ahead.
Okay, so when are you gonna upload this on YouTube? Like,
See?
when are you gonna upload the video on YouTube?
I have to put the video and the sound together first. So after that, I can upload it. Yep. So I would say probably sometime this afternoon. If not, it's going to be in the evening. Yep. Go ahead.
So if you have a Mac, there's an additional step to use right here to do this.
If you have a Mac, you have two choices. You can either run the virtual machine by using Q as the QEMU emulator. If you look up QEMU Mac OS X, you will find it. The alternative, which is probably easier, is to install the development pack for Mac OS X, because that one also makes use of G++. So that might work out just as well.
Which development pack?
I can't remember the name of that.
Xcode?
Sorry?
Is Xcode what you were talking about?
Yeah, Xcode. Yep. Mac OS X. Is it Xcode? Yep. And I think you can get it for free. Can anyone confirm whether that is free?
Yeah.
Okay. Yep. Does it give you the command line tools, or does it only give you the IDE tool?
I think I've only seen the IDE, but if you have Vim, you can do all the
Yep.
command line.
Yeah.
And
Yeah.
Vim, you download.
You might want to stay with the command line tool, because if you use the IDE, the folder structure that it needs to get everything working, it may not work well for the grading script. All right, so that's the Mac thing. Yep, go ahead.
Is there going to be a difference between using G++ and GCC?
Yes.
Okay.
GCC is a C compiler. That's what the CC is. G++ is a C++ compiler. So you definitely want to use G++ and not GCC.
Okay, because I couldn't get GCC to work, so that's...
Yep, that's probably why. Yep.
Where do you find the videos on YouTube?
Sorry?
Where do you find the videos on YouTube?
Oh, that's a good question. Where do you find the YouTube stuff? Okay, you go to YouTube, and the quickest way to get to it is just YouTube/someprofs. SOME. I know you guys cannot see it. Let me move the window down a little bit. There we go. Okay. So it's just someprofs, SOMEPROFS. So once you get to the channel, click videos, and when you go to videos, it will list all the uploads in a reverse chronological order. So whatever I upload last will show up first. Okay. So if you're curious about what I teach in my other classes, feel free to click on any of those links. If you have insomnia and you need some help to fall asleep, feel free to click on anything here. I heard it's very effective of putting people to sleep. And there's no side effect other than, hey, I woke up knowing how to program in assembly. How did that happen? Any questions? No? Okay, so give yourself a little bit of time to get through this, because I know there are a lot of steps, but if you do it a few times, you'll get used to the process and it won't be a problem. Oh, one more thing with the homework assignment. It's actually inside the description here. It's how to turn off the virtual machine, because I remember I said don't click that close button. So if you're not going to click the close button, how are you going to shut it down? You have to change to the root account first, okay? Log in as the root account. If you already logged in as user, you have two ways to do it. One way is to log out first and then log back in. The other way is to use the SU command or switch user command. If you type SU on the command line and then just press the enter key, it is by default switching to the root account. The password of the root account is BEER, B-E-E-R, lowercase, and that will log you into the root account. And the reason why you know we are in the root account is because of this part. So when you log in as root, you can type power off as a command, and that will start the sequence to shut down the machine. If you accidentally click the close button, don't panic. It's not going to be a big deal. So don't panic if you just say, "Oh man, I just clicked the close button." It's probably going to be okay. All right. Any other questions? So now, the way it is right now, what I can do is I can detach my hard drive, which I'm not going to do because the recording is still recording to the external hard drive. But if I am not doing that, I can unplug this hard drive, go to the library, plug it in, navigate to the Linux folder, double click on Start 64, and be able to run the virtual machine over there. That is the reason why I'm doing this, because it is a very portable solution. You can do it anywhere you want to. Any other questions? No other questions? And this is not enough reason that someone's gonna drop the class? Nope. All right, well, that's good. That is good. All right. I just want to do one more thing. Why are you guys interested in computer science classes? I know some of you have to take this class because even in math, you have to take CISP 360. But for the rest of you, if you're planning to become a computer science major, why did you pick computer science or engineering as your major?
Playing with the code for me is fun.
Okay, that's fun for you. Okay. It's fun for me too. I would much rather be coding than, well, I'm not gonna say it, but I just like coding. Yeah. Anyone else? Well, I heard there's a lot of money in this industry, right? Doing this for money is, I don't want to discourage people, but I'll just be honest. Not doing programming because of the money is going to be painful. If you like doing this and you're making money on at the same time, it's good. Okay, but doing this just for the money is going to be painful because programming takes a certain type of personality and certain types of a certain type of person to do it right. Okay, I'll let you guys describe what you think would be a right personality to do programming. Logical, analytical. Okay, so when your program doesn't work, what are you gonna do? Pound on the desk, throw the monitor, scream, curse.
Maybe. And
none of that is gonna work, right? You just have to figure it out, okay? Step by step, okay? Now this is not, I did not make this part up, okay? I was a TA at UC Davis a long time ago, okay? And as a TA, I have to go down to the computer lab, which is a subfloor, and help out the students to get their homework done. So on the night when the homework was due, there'll be a lot of people, panicking and frantically trying to get the homework done. When the programs do not work, what do you think these people did to try to get the programs to work? Random changes. They would do random changes to the program, hoping that one of these random changes will fix the problem. It's almost the same thing as, I'm not sure whether any one of you remember cars when they still have like vacuum tubes around in the engine compartment. Have you guys seen cars like that? No? Okay. I'm trying to find an analogy, but we are running out of stuff that is of that nature. it's kind of like opening up the hood, your car doesn't run, and you just kind of randomly reconnect stuff. Like, oh, I don't think that should connect here. Let me plug it here. The plug doesn't even match. You know what? It's not a problem. I'll just splice it, and hook it up. And hopefully one of these things and one of these fixes will fix the car and it will start up. That was the thing that I observed when I was a TA at UC Davis. Okay, definitely not the right way to do it. Okay, even falling asleep and taking a little break would be much better than making any type of these random changes to a program. How many people like problem solving? Okay, you are suitable for programming because programming is a lot of problem solving. Okay, writing the code is problem solving, and guess what? Debugging a program is even more of a problem solving process. So, so that's kind of it. Any other questions about this class or anything that we talked about today? Yep, go ahead. Tell you about my background. I was in industry officially full-time from maybe 1989 to 98. I worked for a company called Z-World in Davis as a developer. And when I said a developer, it's kind of like a lead role because I was the first software engineer for that company. So I was kind of in a leading role throughout my employment over there. I worked on compilers, I worked on embedded controller, software, firmware, a little bit on the hardware side, a little bit on the software side. I also wrote helped develop the IDE of the compiler that I was working on, which is in Windows. So that's kind of some of my programming background. Any other questions? Okay, no one is asking the obvious question. Are you really qualified to teach this class?
You liked it. You liked working in that environment.
Did I like working, or why did I?
Did you like it?
I really enjoyed working for a small company. I have never worked for large companies, but working for a small company is really fun because you get to see everything. And there's no way to compartmentalize, when you are working for a small company. When I say small, it's 22 employees when I started. You basically have to pick up, different roles. When I first got hired, I was the only software person. So I was doing development, debugging, not only debugging software, but also debugging the hardware. Because the guys who designed the circuit boards always blame it on software. I would go up to them and go like, hey, this is not working. I think there's something wrong with the hardware. And they always say, no, tech is all in the software. You just need to check your own code. And that's why I learned how to read schematics, so I can point out to the hardware engineers and say, I think this is supposed to go here and not over there. I was doing tech support along, when I was a developer, and that didn't work out too well. I would be focusing and doing my coding, and then the phone rings, and then I have to answer the call. That really just doesn't work out. Let's see, what else did I do? Anything that has to do with software, in that company, I had to do it, as a small company. Did that answer your question? If you work for a large company, a lot of times you don't have the option to really just kind of walk around and see what other people are doing. Any other questions?
So after we finished this class,
right?
Because I was interested in learning a lot of languages, but one of my top priorities is Python.
Okay.
So all my CAD programs have script plugins for Python.
Mm-hmm.
So how similar is Python to C++?
Well, you just picked one, scripting language that is not similar to C++. The only one that is not. Okay. If you look at most scripting languages like PHP, Perl, even shell script, they all resemble C a little bit, okay, in terms of syntax. Python is the only one that does not resemble when it comes to syntax. But when it comes to programming concepts like loops, functions, subroutines, parameters, and stuff like that, arrays and stuff like that, a lot of what you learn in this class would be applicable in Python programming.
Okay.
Yeah, but C programming is kind of special in a way because C is a programming language. Okay, who came up with this programming language? I mean, this is a quick quiz. You can use your Google search.
Richie.
Yep, Carnegie and Ritchie. Okay, so those are the two guys who came up with the C programming language.
Bell?
And
At Bell Labs?
at Bell Labs, exactly.
Yeah.
And what were they doing when they invented the C programming language? They were developing Unix. And those two guys were writing Unix in assembly language, which is kind of the same thing as building a castle using individual grains of sand. Okay, so before long, those two guys got kind of bored because it's not like whether they can do it or not. It's like, wow, this is really a lot of chore. So they invented the C programming language as more or less a macro language, so that they can say, if I just write this one line here, the compiler will take it and expand it into these instructions, so it can save them time. Okay, but they wrote C for themselves. It was never ever intended as an instructional programming language. So this is similar to a tool that a carpenter makes for himself.
Okay.
Okay, the carpenter says, oh, I don't really need to hide this edge here. I know how to use this tool. So it may not be user-friendly. It may even be dangerous. But to the professionals, it's like, oh, this is a good tool. I know exactly how to use it. And they used it effectively and wrote Unix, which is a fairly complex operating system. So now here you are, as a student, using C as an instructional programming language. And what do you think is going to happen?
I don't know.
You're using a circular saw with no safety feature whatsoever, and a blade that is supremely sharp.
Someone might get hurt.
You have to be careful. Okay, so there are books. I just want to make sure that you guys understand what C really is. Come on. Okay, there's a book called "Leave Enough Rope." C programming. I think that should find it. There we go. If you can find a book with this title, I think that should tell you something, right? Enough rope to shoot yourself in the foot, which basically means in C and C++, you can make a lot of type of mistakes to screw up the program. Now, you can do that in any programming language. In Pascal, I can screw up a program too. But the way you can screw up a program in C and C++ makes it extremely difficult to find out what went wrong with the program. Okay? I'll give you one quick example. You guys will see it again and again. 2 equal symbol is entirely different from 1 single equal symbol. Even though in certain cases, one can take the place of the other one syntactically, but the meaning is entirely different. So if you use the wrong one, your program may work occasionally, and then other times it does not work. Same thing with double ampersand versus a single ampersand. Okay, they both mean and, but one is logical and, the other one is bitwise and. And the worst part about this one is it may work perfectly okay with one environment, with one particular compiler, and then you switch to another compiler and everything falls apart. Okay, so C is filled with stuff like this. Okay, as we go along, with programming in this class, I will point out most of these traps. Okay, and just basically say, pay attention to this thing here. Okay, because if you use the wrong one, the compiler won't complain. The compiler says, yeah, you can use this or you can use that, and it will generate the code accordingly. And the worst part is it doesn't break your program right away. It might even work for a while for certain cases, but it doesn't work all the time. Those are the worst type of bugs because if your program breaks consistently the first time, hey, you can debug it. If your program does not break consistently, then you have a problem. So I will try to point out those things in this class, as we start to get into the syntax and different types of features in C and C++. All right. Any other questions? Yep.
I'm a chemical engineering major, so computer programming is not really like my interest or proficiency.
Okay.
So my question is the material manageable enough that with your direction and with like a solid work ethic, I can still figure out everything that we're doing and be very good at it, or is it something I'm going to need a lot of supplemental help with because of the fact that I'm not super computer oriented or skilled?
I would make every effort to make that true, but there's no guarantee.
Okay.
Yep. But do you know why cisp360 is required with your degree, with your
Well, I'm
certificate?
sure that there will be some points that I'm going to be using research data and I'll have to create a program to either read that or program it myself.
Yeah, I would say the way I teach this class is definitely geared to people who are transferring to a computer science program. That's the intent of this class. So you will probably have to learn something that you may not need to use ever again, like pointers. Because I can understand you need to use loops, subroutines, and stuff like that in any programming language. But pointers are kind of unique to C and C++, or the way it is implemented is kind of unique to C and C++. So I would say certain parts of this class may not be that useful in chemical engineering. But in terms of control structure, how to write a program, how to debug a program, the approach itself is still going to be applicable. Anytime you want to do any type of scripting to specify the logic to do something, it's going to be useful.
Okay.
Yeah. But there will be a lot of stuff that I understand what you're saying. It's like, wow, it's all this stuff, and all I really need to get out of this class is this much.
Well, I just want to make sure that the material's not so like up there that I won't be able to understand where it's applicable or how I can get through it without having a lot. I mean, I use my computer for research and for writing paper occasionally, but like other than that, I don't use my computer for anything. So my computer skills are like pretty limited.
Well, let me ask you.
I have the prereqs and stuff, but that's just I learned it and dumped it.
Well, let me ask you this question: what do you do as a chemical engineer? When you do become a chemical engineer, what do you do?
Depends on what field I'm in. What do you mean?
Pick any field.
Medical.
Medical? Okay, so what does a medical chemical engineer do in industry?
In the industry, well, you could be creating the plastics and the polymers that are used as tools or as supplemental, surgical devices and things like that.
Okay, so let's say you have, you have 5 different types of chemicals, 5 different types of polymer, and you have some sort of test procedure to test characteristics of the polymer that you have just created. So how do you do that?
Well, you obviously have to program in the research and the data that you have.
Exactly. So if you want to do any type of automation, like, okay, this is the process to test a particular block of polymer for thermal conductance or whatever, okay? If you can specify what to do and tell the computer to do it the same way as you would do it by yourself, then you have just automated that process. Now, what is the big thing, or what is the advantage of being able to automate something? Computer science is all about automation. Okay? We automate what at the end of World War II? For those of you who watched the movie, The Imitation Game, what did they automate with the Colossus computer? Breaking code. Okay? So it was a process. It can be done by by hand, manual, but it will take a lot longer to do it manually. So by automating it, they can now have really fast, well, at the time it was really fast, computers to automate that process. Okay? What else do we do in an automated way these days with computers? I have one example in my mind, but it was, and then I thought about it, it's like, well, maybe not really a good example. But it was kind of fun. You guys want to hear about it? Sure. And not hold me accountable for it? Auto flush in the toilet. It's automation. It is automation. Okay? It's actually a bad habit forming automation. Okay? Driving, self-driving cars. That's automation, right? In year 2020, you will be able to buy a car off a lot with auto drive capability. In fact, if you buy any Tesla today, it is already capable of self-driving. That's automation. Now, in chemical engineering, it's not just the testing of a material that can be automated. The research and the refinement of a material can also be automated. In other words, you figure, okay, this is just an example because I'm not a chemical engineer. So let's say you figure out 70% of this stuff and 30% of this stuff give you a reasonable mixture with some of the properties that you want, okay? But it's not optimal. It's just close to what you want, okay? So if you can automate a process, using robotics, and basically say, okay, I want to test everything from 62% versus 38% to 75 versus 25%, and go by 0.5% intervals, and have that whole thing automated. Then at the end of the day, you just write your script, set up the robotics, fill in with all the chemical stuff that you need, and you just walk away. The next day when you come back to work, the computer or the robotic system would have finished the testing already, and it can tell you exactly 71.5% versus the other one is the best, the optimal mixture to make this polymer to meet all the requirements that you need. Are you seeing the value of being able to automate something in chemical engineering?
Yeah, absolutely.
Yeah. So this class will get you some of the tools, some of the skill set that you need to write programs. Not like that one, not to automate a robotic system, but at least the basic stuff so that you can understand programming in general. But at some point, I think in your career, you will see a lot of automation. Anyone who's going to be graduating in the next 5 years will have to learn about automation, regardless of the major. Is that making any sense? Any other questions? So that's a good question. I would try to balance, between what computer science people really need to know to move on to other computer science classes, as opposed to math major, chemical engineering major, where it's not your main thing to do, but it is still important to understand programming. Anyone who's going to get into computer security? No one. Wow. Okay. Well, computer security is one of the few industries where employment will be abundant. Okay, there will be a lot of open positions for several reasons. Okay, reason number one: can we outsource, security to other countries?
Yeah, I mean, you can. It's
Not a very good idea, right? Okay, very good. Two, okay, in terms of most programming jobs, you are in a competitive environment where you'll be competing with other companies. Gaming, doesn't matter what it is. But in computer security, it's not just competitive, it is what? Adversarial. Okay? One side is actively trying to break into the other side, right? So what does that have anything to do with employment? Will there be a lack of job opportunities? Who are orchestrating, hacking into computer systems in the United States? Are we talking about individual hackers, just doing it for fun?
Chinese.
Okay, and what is the population of China? 1.7 billion, okay? And what is the population of the United States? Okay, so there's a scale of difference in terms of just sheer population. Are there any nationally run, federal government run hacker school and organization in the United States? None that I know of. If there's any, it's understaffed. Okay? And is China the only country who has a record of trying to break into US systems? Okay, well, what is the world population? 7 billion versus 300 and something million. That gives you a scale of what type of threat we are dealing with when it comes to cybersecurity. Okay? Now, cybersecurity is interesting in a way because when you talk about real weapon, then you're talking about a big, huge, long supply chain that has to be in place. Okay? Back in the, I think, 80s or the 70s, the Americans could have given the Russians the plan to make the SR-71, and it would just quicken the downfall of the Soviet Union. Why? Because they don't have the material, they don't have the right machines, they don't have the infrastructure to make something like that. They can imitate the shape, they can imitate everything on it, but it's not going to be functional. Okay? But what about computers? You don't need the top-end computer to become a hacker. Is that making any sense? So it levels the playing field like there's no tomorrow. Now, if you think about it in the flip side, does anyone know what is the X47B? X47B. Okay, I'll look it up for you. X47B, if I remember correctly. Yep, that is it. That it is. Okay, so you're looking at a miniature B-2, but it's not a miniature B-2. A B-2 is a bomber, okay? It takes people to fly it. This is a drone, okay? And you look at this, go like, well, it's kind of like an odd-looking drone, but somebody's going to remotely controlling it, and just like any other drone. Nope, this is designed to be a fully autonomous drone, which on paper sounds really great, right? Because some military decision maker can just drag and drop and destroy a target. Wow, that is great. What was the main topic again? Computer security. What if someone breaks into it, the control system of something like this? What would be the consequence of that? We are not talking about one, right? If you figure out how to break into one, you can break into all 5,000 of these things, all at the same time. What would be the consequence of 5,000 of these things getting compromised all at the same time? Not pretty. The worst part is, what if they have already broken into it but decided not to do anything about it yet? It's even worse, right? Because you basically have a hidden component in the control system of these things that is just dormant for the time being. Until it is needed, nobody's going to find it. So computer security is more and more important because we got stuff like this. And there's no option. We cannot say we don't have money to hire more computer security people. There's no option, because the moment we stop, defending the systems, is the day when what happens? The hackers will be in. Okay, so that's why I want you guys to at least think about computer security and see if you can find any relationship between computer security and programming, because those two things are very closely related. If you really kind of think about it, they are really related. Even though at school we have CISS, discipline, and then CISP discipline, and they don't seem to be connected, but they are actually closely related. We are running out of time. I don't want to stop you guys from getting lunch, because I have to get my own lunch too. So I'll see you guys next Monday, and don't forget about the homework assignment. Get started early. Not yet. I got only one person who did not show up. So not. I don't have any ad yet at this point.